For section 4.2, we are going to be talking about expected value and standard deviation. So we've already mentioned that term standard deviation before. Expected value will be new. So let's take a look at these. First, the mean. And we've talked about means before, but we haven't done them with probability frequency distributions. So the mean of a discrete random variable is mu sub x, so remember that's the mean of the x values, and we've got that sigma symbol, which means once again we're going to be adding things up. So what are we going to add? Well, we're going to add the individual x value times its individual probability. And then once we have done that with each of those individual x values and individual probabilities, we will add all of those values together. Notice x is the value of the random variable and p of x is the probability of observing that value of x. So we're going to compute the mean of the probability distribution that we were given in example 4.3. So the first thing that we do here is we're going to multiply x times p of x, and you can see that this column right here has that label. So 0 times 0.06 is 0. 1 times 0.58 is 0.58. 2 times 0.22 is 0.44. 3 times 0.10 is 0.30. 4 times 0.03 is 0.12. And 5 times 0.01 is 0.05. So then what we're going to do is we're just going to add all of those values together. So I'm going to grab my calculator. We've got 0 plus 0.58 plus 0.44 plus 0.30 plus 0.12 plus 0.05. And when we add all of those up, we get 1.49. So that is the mean of this particular probability distribution. So notice your values run from 1 to 5, but because of the probabilities of each, you can kind of think about that as how many times those values would occur. It centers out so that the mean ends up being 1.49. So kind of in this area right here, because notice that's where most of your values are going to be. So that is our mean for that table that we were given in example 4.3. The expected value is the average gain or loss of an event when the procedure is repeated many times. What we find out is the expected value is obtained by taking the sum of the products of each outcome and the probability of that outcome. So we calculate it exactly the same way that we would calculate the mean. If the expected value of a game is 0, it is called a fair game, and that means that neither side has an advantage. So expected value, we're going to look at that. 4.6, in the game of roulette, a player can place a $5 bet on the number 17, and he will have a 1 out of 38 probability of winning. That's because there are 38 total numbers, and one of them is a 17. If the metal ball lands on the 17, the player wins $175. Otherwise, the casino takes the player's $5. What is the expected value of the game to the player? And then if you play the game 1,000 times, how much would you expect to lose? All right, well, I guess that part is telling us that this is probably not a fair game. It's probably in the favor of the casino, but let's take a look. So we want to think about what our outcomes would be. If our ball lands on a 17, so let's just talk about outcomes here. If our ball lands on a 17, then think about what has happened. We have bet $5 and we have won $175. So the net result of that is we get a positive $170 outcome. oh wait, that's outcome. This is, we'll just say this is the result. Okay, now that means there is a probability of 1 out of 38, we were told. So there's one chance out of 38 that the result, and actually these go together. This is what's going to happen on the wheel, but the result is, the outcome is that you win $170, and the probability of that happening is 1 out of 38. Next, we've got all the other numbers. And so we know there are 37 other numbers out of 38. And so that is basically not 17. And so the result of this is we lose $5 because we bet $5 on a certain number, and on 17 in this case, and we did not get a 17. So one time out of 38, you're going to win $170. The other 37 times out of 38, probability-wise, you're going to lose $5. So we're going to take our value here and multiply them together. So x times p of x. So this first one would be, I'm just going to leave it right now as a fraction. So 170 out of 38. And then this one I'm going to need to multiply. Negative 5 times 37 is negative 185 out of 38. And if we add those together, 170 over 38 minus 185 over 38, we're going to get negative 15 out of 38. Now let's go ahead and divide that and turn it into a decimal number. It would be negative 0.395 if we round it off. So that is our expected outcome, negative 0.395. And that means, on average, we would lose almost 40 cents per time that we played this game. Now, if we played the game 1,000 times, how much would you expect to lose? Well, I kind of just answered that. If we played 1,000 times, and on average, the end result was that we were losing 0.395, so almost 40 cents per time, we would end up losing $395. So that means we would lose $395, and that would be the answer to that part of the question. So the expected value tells you kind of on average what you would expect to happen if you played the game multiple times. And so in this case, this game is not a fair game. It is shifted in the favor of the casino just a little bit, not a ton, but that's probably how most of the games at a casino are set up, so that it doesn't seem like it's super stacked against the player, but in the end, the casino is probably going to win out most of the time. Example 4.7, a term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. These policies have premiums that must be paid annually, that means every year. Suppose a life insurance company sells a $250,000 one-year term life insurance policy to a 49-year-old female for $530. According to the National Vital Statistics Report, Volume 47, number 29, the probability the female will survive the year is 0.99791. Compute the expected value of this policy to the insurance company. So let me go to the next screen so I have some space to work. So here are the important values. When we look at this, we're finding the expected value of this policy to the insurance company. So the insurance company is guaranteed to get $530. So that is a probability of 1. They are guaranteed to get that money because they're going to, we'll just put a little X here. They're guaranteed to get that money because that is what they charge for that term life insurance policy. That's what it says right here. So they are guaranteed to get that $530. Then there is also the possibility that the insurance company has to pay out $250,000. Okay, now, well, actually, hang on. I want to make sure that this makes sense. So, all right, let's do this a little bit differently. There is assuming that she survives, there is a 0.99791 chance that the company will get $530. Now, if the lady does not survive, that probability will be the rest of this. So let me subtract this on a calculator. 1 minus 0.99791. And that will give us 0.00209. So that will make our probabilities add up to be 1. Now, in this case, the person still pays in the $530, but then the company has to pay out $250,000. So the end result of those two situations, of those two things happening, is we're going to take 530 minus 250,000, and we're going to get the net result of that situation is the company is paying out or losing $249,470. So to find the expected value of this policy for the insurance company, again, we're going to do X times P of X. And we're going to take 530 times 0.99791, and we're going to get 528.8923. Then when we multiply the other one, negative 249,470 times 0.00209. And that is negative 521.3923. Then we add these together, plus, and when we add those together, we get, since this is money, it's 7.5, but since it's money, it's $7.50. So the expected value of that policy for the insurance company is $7.50. So even though the lady is only paying $530, there is most likely she's going to survive the year, but there is that slight chance that she might die during that year. And so then the company has to pay out all that money that it has for the policy. And so the end result is if they gave out a whole bunch of policies like that, they would end up making $7.50 on each one. Now, the truth is they might have some years where no one dies in that age group and they're making the $530 on each one. And then you might have some years where a couple people die. And so it's just, that's the game they play, but this is calculated. You saw those numbers. If you look back, they have calculated this of how likely it is that people will die. And so that's what all this life insurance stuff is based on. Now, if we want to find the standard deviation of a discrete random variable x, this is given by these two formulas, and either one of these will work. And the formulas, if you look what they say, you've got the sum of this product. And so what we're going to multiply is we multiply the difference between each individual x value and the mean, and then we subtract those and we square that quantity and then multiply that by the probability of those individual means. So you can see this would take a while to do it, and we're not going to do this. We're going to let the calculator do it for us. An alternate option here is to take each of the x values and square them, subtract from the mean, and then subtract the mean of the whole group squared, and then take the square root of that answer. So there are a couple different formulas. They each work. They both basically do the same thing. They're just set up a little bit differently. But in this case, remember that x is the value of the random variable. Mu sub x is the mean of the random variable. And p of x is the probability of observing a value of the random variable, the specific one we're talking about. And then if we wanted to find the variance, we would just take that standard deviation that we calculated right here, and we would square it. So that is the formula. Again, we're not going to have to do that. We're going to allow the calculator to do this work for us. So here are the steps for doing this on the calculator. To calculate the mean and the standard deviation of a discrete random variable, first thing we will do is enter all the values of the random variable in L1, as we've done before, and their corresponding probabilities in L2. Then press the Stat key, go over with your right arrow to highlight the Calc menu, and then select number one variable statistics. So we've done these steps before, just in a different context. With one variable statistics appearing on the home screen, press second, then 1 to enter the L1 if it's not already there for your X list. For the frequency list, press second and then enter 2. You can't see it behind my little thing there, but enter 2 to insert the L2 and then press enter. So example 4.8, we're going to compute the variance and standard deviation of the discrete probability distribution from example 4.3, and we're going to interpret that in context of the Netflix movies streamed each month. So remember, the first thing that we will do is we will go to Stat and Edit so that we can enter in our values. Remember, if you have something here, go up, highlight L1 and hit Clear Enter, and then go over to L2, hit Clear Enter, and that will get rid of those values. Now, if we are going to enter these in, we've got the X values are from 0 to 5, so 0, 1, 2, 3, 4, 5. And then their corresponding probabilities, 0.06, 0.58, 0.22, 0.1, 0.03, and 0.01. And we've got those values. And then once we have typed those in, we're going to go back to the Stat menu. We're going to go over to Calculate and choose number 1, one variable statistics. Now notice the list is already list 1. That's what we would want it to be. We're going to go down to the frequency list. We're going to push second 2, and that gives us list 2 as the frequency. And then we're going to go ahead and calculate this. And so notice, and we already calculated this earlier, but X bar, the mean of this frequency distribution, is 1.49. And we did that by hand, and we got that exact same answer. Then notice it calculates that other stuff, but the one we're interested in here is the variance and standard deviation. So we're going to write down the standard deviation, which is sigma sub x, and that is going to be 0.933. Does it say how to round it? Okay, 0.933 is how I'm going to round that off. Now, when we want to find the variance, which is sigma squared of x, what we want to do, we do want to keep some extra values. So if we want 3 decimal points in our final answer, we need to keep the 932,684. We need to keep twice as many of those values so that we can round our final answer off to the 3 decimal places. So again, remember, any of the in-between rounding, we keep twice as many decimal places as we need for our final answer. So that's why I kept 6. So I'm going to go ahead and do 0.932684 and square it. And so then we would find out that sigma squared of x, which is the variance, is 0.870 if we round that off to 3 decimal places. So there's your variance, there's your standard deviation. And so it's very easy to do that if we have the calculators, and that's why we're not going to worry about trying to mess with that formula. It becomes a big pain. So we're going to go with that. So there's example 4.8. That is the end of section 4.2. You've got your 8 graded problems to work on. Make sure you use your calculator for some of these things so that you can practice and get ready for the test when you'll be able to use your calculator again for that. And don't be afraid to send me a message and ask me for help on these.